So let's start with the topic of our interest. Our interest is in understanding the stimulated emission. Stimulated emission. There are the three basic concepts in this chapter. These one. First one is spontaneous emission, stimulated emission, and third is absorption. So when we go to the atomic state, there are two energy levels, right? First, we have to discuss about the energy levels. So definitely, when we say or when we talk about the energy levels, there will be a suppose there will be a two isolated energy levels. First one is known as E2 and E1. It's just I'm writing here E1. So there will be already a scenario in which the energy of E2 is always greater than the energy of E1. So whenever an electron resides in this energy state, this will decay down to the energy state 1 with emission of N. And what is this? This is nothing but a photon with energy h times nu. Nu is nothing, a frequency. So let's go to the slide that is just here. So when there are two energy levels, when we never shine in a photon on it, it decays naturally. There is a tendency of in any system is to gain a stability. So when an electron in a higher energy state, like E2, this will decay into the low energy state or stable energy state with the emission of a photon with the energy h nu. This energy h nu is equals to the energy difference between two levels that is mentioned here, right here. This is E2 minus E1. Suppose and the energy of E2 level is 5 electron volt and the energy of E1 level is 3 electron volt. Then the energy of photon will be 5 minus 3, that is 2 electron volt. So this is all about the spontaneous emission that is occurring spontaneously without any external agent. So let's come to the point that is interested here in the construction of laser idea, that is a stimulated emission. Stimulated emission. So what is stimulated emission? In stimulated emission, we use an external agent by which we can help or we can done work on a electron which are in a higher energy state, and this will jump to the lower energy state just like a spontaneous emission. But in this case we are shining in a photon and forcefully making this electron to decay from higher to low energy state. So there will be a two photon emitted. One is shined photon and the other is the photon that is emitted by the decaying of this electron from high energy state to the ground energy state. Well, in this process, we used a one single photon, there will be a two output photon. This is the main idea that is used in the manufacturing of laser. So there will be a third case in which when we shine a photon, if electron resides in low energy level, just is simply absorb the energy and go to the higher energy level. So we are not interested in the absorption as well. We are interested in this stimulated absorption. So let's come to the next page, this chapter. Yes, this one. No, this one. Right here. Yep. Let me remove something. Let's remove this one. Okay. So we can easily understand this. Let's see here, spontaneous emission. Spontaneous emission, the rate when we use dN by dt. N2 is nothing but the population of electrons. Don't know, there is a number of electrons in energy level 1. We are just considering the one electron in upper diagram that we used, but it is used to simplify the basic idea. But there is not a single electron residing in a single energy level. There must be a number of electrons. So we are using the N2, number of population. So the rate at which N2 decays equals to the negative times N2, means as much as N2 the rate will be larger, and A is the something like a decaying constant. A is nothing but the Einstein coefficient. Einstein coefficient is optimal coefficient, that is quantities tau spontaneous equals to 1 upon A, called the spontaneous emission radiative lifetime. It's a constant. So we are not just interested in this constant or finding this constant. We just used the value of A here. Here we use the value of A, which is nothing but 1 upon tau. So let's move to the next slide. So now you can see that W21, we replaced it with where radiative and non-radiative decays. These are the simple formulas. I have formulated for you. Next time I will formulate it. Okay, thank you so much.